Okay, welcome back, students. We get a bit faster now as we go along. So we're to show the triangles are similar. Okay, so they have a common 80. That's cool. But these are not common. So what have 43 and 57 got in common? Well, the question is this 57? And equally important and similarly, is this 43? So let's do some careful thinking about this. And it's this. These must add to 100. That's for sure. So straight away from that, we have that this is 57. These must add to 100. Straight away from that, we have that this is 43. So now we have angle, angle, angle. Okay, and if you see in my notes that I call this the angle A, angle B, and the angle A, angle C situation. Okay, and that A plus B subtracted from 180 is equal to C. Okay. And there are probably other ways, of course there are other ways of saying that. Now what did I say? 180 subtract, I need a bracket there, don't I? Okay. And so basically if you clear the decks here and go, look, there are 4 angles given, but this is common, so if we're to kind of cross it out, acknowledging that it's common, and just go, do those 3 angles there, those 3 unique angles, do they add up to 180? And the answer is they do. And that means you're in business. You've similar triangles, and that means you've corresponding sides being proportional, and that's what it's all about. Okay, so yes, they are similar, and once we know they're similar, we have our corresponding sides, which is this is the full ratio that we know, and then everything else can be calculated. So basically we've shown that they're similar by, I've already said it, with 43 and 57 degrees, that's shown. And find the length of FG. So let's always start off with our variable, and that is our variable FG up top. Find it physically, it's here. Compare it to the smaller triangle, which is 5 in its corresponding place, and then make another and make that equivalent or equal to the other proportion, the fully known proportion, which is 15 to 6. Okay, bring up the 5 and divide in the common 3, and we have 25 over 2. Okay, which is perfectly good answer, as long as we call it centimeters. Okay, let's get through the homework now. Question 3. According to the color coding, the triangles are similar. We'll do these one at a time. Y visually is to 12 as 9 is to 6. Definitely stay away from those 2 there, because then you'd have 2 unknowns with one equation. And if you have 2 unknowns, you need 2 equations. Just a quick little trick here, that any what's it called, any side cancellation is allowed, and any up down. Any rectilinear is the word I was looking for. Rectilinear, like a rectangle. Any cancellation this way, this way, this way, or this way is allowed, but not diagonal cancellation, because that would be totally wrong. Okay, so 6 goes into 12. 2 times 2 pops up on the 9. So y equals 18. Okay, and let's do the other one. X over 9, this divided by this, is again the same as 9 over 6. Okay, that will go up and down. We can cancel left and right, doesn't really matter. 3 into 9 goes 3 times, 3 into 6 goes twice. Up comes the 9 up here, and we have 27 over 2. Perfectly good answer. unless we want to see it decimally, but we don't have to, and we're done. Okay, question 6. Y over 10, just always put a variable on the top left. Y over 10, going that way, equals 18 over 12. Okay, and we're just simply cancelling. I'm going to leave that bit to you. Okay, that cancels down. That's reduce that and you got your answer. Okay, now what else do we need? X. Well, x over 14 is also equal to 18 over 12. Okay, we'll bring up the 14. I'll let you put that in the calculator. That's the answer. Give it the right units, centimeters. Here we have number 9. So all they've done is they've twisted it around, but that's okay. They have the two correspond the equal dot angles. Angle at A equals angle at X. Angle at B equals angle at Y. Angle at C equals angle at Z. The only extra effort we have to do here is finding our corresponding sides. Let's get straight into it. Which of the sides in XYZ corresponds to AB? Well, AB is opposite the double arc. So the answer is XY side, and that's how we say side, because it's a line segment. Explain your answer. Just say it corresponds, or corresponding side. Okay. If you want, you don't have to, because you said it's corresponding, but opposite that. Okay, find the value of D and E. So let's start off with D. D corresponding to the 6 over the 6 equals, now we've gone from here to here, we must find a known couple. So 15 is opposite the dot, 10 is opposite the dot. 15 over 10. Up comes 6. I'll let you do the donkey work if you don't mind. And we're on to D. Here's my D. D over, he's opposite a double. Hang on, did I not just do D? I did E. E was opposite the single. What a mistake. Let's start that whole thing again. Just to be safe. Made a mistake. Okay, D is opposite a double. D is opposite a double. 6 is opposite a double. 15 is opposite a dot. 10 is opposite a dot. Going from bigger to smaller. And up comes the 6. Okay. E is opposite a single. 9 is opposite a single. Equals. Same fraction again. 15 over 10. And up comes the 9. I'll let you do the donkey work if you don't mind. We're driving on to number 12. Okay. So the upper triangle is proportional, is similar to the whole triangle. And there are other little tricks here too, like this bit is to that bit, this bit is to that bit, and so on. So there's loads we can do here, but we better find a question. I'm not going to find the situation because I can see the situation. I'm going to just go straight for the question. Explain why the triangles are similar. Okay, well, this equals this corresponding, because what we have is, we have this side here is a transversal to two parallel lines, and this is a transversal to the same two parallel lines. So explain why. So unless I'm going to go and introduce extra things like this, which I can do, so I could say the dots are congruent corresponding. You will get full marks for this. Okay, now the reason I introduced the dot is I'm kind of reluctant to have to go and chase out the 3 letters for the angle. I could do that too though. I could have gone angle ABC is congruent to angle ADE. And saying it's congruent is not enough. In geometry, you have to say y, corresponding. Okay, and similarly over here. But I mean, the easiest way is just to introduce a new symbol and say something like the individual are congruent because of corresponding. And that's it. We got 2 angles is as good as 3. Okay, so that's my angle explanation done. You have to be creative. You have to be productive. And you get your marks in there. Now find length DE. Where is it? Here. Okay. We've already got a variable name for it as long as we use this, but you could also introduce an X or something. Not going to. I'm going to use this. There's nothing wrong with it. And the exam marking scheme will use that. So DE divided by 8, biggest triangle divided by the smallest triangle, equals, now we're going from the big triangle which has a 7 in it, the small triangle has a 4 in it. Up comes the 8, 4 goes into it twice, so DE equals 14. Let's give it a new line. DE, line segment, now distance DE equals 14. And then give it units if it has units. If it doesn't have units, we still give it units. We give it units of units. Okay. On to 15. Lovely. An application, and this is where you'll see my notes that I posted there to Teams. This application demonstrates an application of similar triangles. Okay, so let's find a question. We can see the diagram. Most of this will be repeating what's in the diagram. What do they want to know? We could nearly guess, could we? It's hard to see. How high is the tree is probably a question. How tall was the tree? So it's nice also to think, what are they probably asking, like I did there. It just makes you feel in control and you're not being bossed around trying to figure out, having people demand stuff of you. Nobody likes being told what to do. So feel like you have agency by saying, looking at this, it's obviously the height of the tree. It's just it's a cool thing to do. Okay, so we have our small triangle over here and our big triangle here. So this over 5, just call it T for the height of the tree, over 5 equals 20 over 50. You see those two are together, the compound long length. Okay. 5 can cancel with the 5. That's now 10. 10 into 20 is 2. So like I said, all cancellations that way are valid, that way are valid, that way are valid, and that way are valid. Just do not ever try to cancel diagonally. Okay, the tree is 2 meters tall. Does that make sense? Does it sound like a tree? Yeah, it's smaller than a tree. Lovely. Okay. So what is going on here now? Well, first we don't have to do that one, so that's okay. 18. Now, in terms of similar triangles, I'm thinking, and now remember I always told you that, you know, a more difficult form of problem is one that needs a construction. Okay, so this is problem solving at its best. We look at it and say, sure, that's not similar triangles. That's it's not even a trapezoid, is it? It is a trapezoid, is it? Because it has the 2 parallel sides and then it's a quadrilateral. Yeah, it is a trapezoid, but we can't really exploit the fact that it's a trapezoid. We need to put in a construction line across here and say this is where we're playing. This is where the action is now down at the bottom here. I think. Okay, well let's just take a further look and try to find some sort of a question or think what is the question. The question is obviously how long is this? Okay. So I'm going to remodel myself like I said there with that construction line across here. So we're going to have a bigger triangle and a smaller triangle. But the thing is, this bigger triangle is 4.5 take 1.5 is 3. And the smaller triangle is 2. And we still have 20 meters here. And this is the unknown. So small triangle L to big triangle 20, which corresponds, equals 3 this corresponding side over this side. 2 cancels with that, leaving 10 up to there is 30. L equals 30. That can't be right. Things have gone pear-shaped. And probably went in the wrong direction, didn't I? So there's where common sense has saved my bacon here and allowed me to spot a mistake. And that's a genuine mistake. No, lads, I'm not doing this to be clever or anything. I genuinely made that mistake. And look, if I make a mistake, you're probably making mistakes. No, we're not, sir. You're the only one making a mistake. Maybe. I imagine, though, some of you are going to make the same mistake. So what I want to see is, I wasn't maybe careful enough to think, am I going from small to big consistently, or the other way around? And I was going from small to big, and a little bit as for a change, and that's what caught me. So this time I'm going into it a bit clearer. I'm going from L to the 20 across here equals, now I remember it was a 3 and a 2, wasn't it? 2 and a 3, yeah. And I'm going from small to big, so from 2 to 3. Now things are looking a bit better. Okay, now the 20 comes up to 40, and we got 40 over 3. Perfectly good answer. It won't reduce anymore. Don't be consistently a slave to decimals when you can be using fractions. Okay, so 40 over 3 meters is a maths answer. It's not an engineer's answer, but it's a very good maths answer, and it'll do me fine, especially when dividing by 3 gets so messy. Okay, and that's it. I'll just check that last one there. Of course they'll have decimalized it, because they're, of course they decimalized it. But why go to that extra effort? Well, they didn't decimalize it, so they gave it as a mixed number, which is even more yuck, because mixed numbers are really not something we like seeing in maths books. That's not good. Anyway, and so only for me to say, you know what I'm going to say, as always, see you in the next one.